Hello fans of GeoGebra. We have a new problem today which I think is interesting from a pedagogical point of view. We have a simple structure, pin-ended elements, and the gap signifies that moment is not being transferred. We have a floor load, we have a modulus of elasticity and an allowable bending stress. This could be mass timber, for instance. And then we have the ability to draw the bending moment diagram on the secondary member or the tertiary if you had tertiary beams. Here it's WL squared over 8 is the peak. You could see it there. I can calculate that in any units I want. In the United States, we use imperial units, foot-pounds. But then we switch to pounds per square inch on the element level. We could also check the bending deflection, compare that to an allowable of perhaps length divided by 360. Again, the units are important. And then the secondary members transfer load to the primary members. The load flows from the secondary to the primary, from the primary to the columns, and of course the bending moment diagram reflects that structural configuration. You could change the dimensions, of course, of the building. We typically at Cal Poly like to have the primary element on the short axis, but we could just play with this as we want. So for instance, space 1, 2, we could change that to something like this, where now it's 15 feet in one direction, 14 feet in the other direction. We could see the influence of that. Perhaps we could change the design of our section. So all of our properties are based on the cross section here, but I could change that to be, for instance, dressed dimensions, or perhaps some kind of glue lam where it's or engineered wood, and everything updates automatically. You could see that the statics don't change, of course, the stresses change. So it's a nice, I think, feature. And then obviously you could draw the bending moment diagrams to any scale, and they're to the same scale, right? They are to the same scale, which is another great lesson, I think, for the students to draw things to scale so that they can see, all right, well, that bending moment, looks much smaller than the other one. Or, for instance, that bending moment might get to be kind of big in that configuration, right? Drawing it to the same scale. So lots of fun lessons here, super easy to program and super interactive, and I hope you enjoyed the video.